What is up, ET350? My name is Daniel Isaacson, and this is my motor. This is a photo of our motor in the operating position. You could see that current flows out of the positive terminal of the battery through the armature, out of the armature, into the negative terminal of the battery. This is not to be confused with electron flow, which would go from the negative terminal of the battery through the armature, out of the armature, and to the positive terminal of the battery. Current first entering the armature goes through the conductive coil, which has been rid of its insulation. As current flows through the armature, you can see it rotating in the blue arrows. And then it goes through, which is located on our actual armature, the green tape. Out of the green tape, it goes into the commutator coil section of the motor, which has half of the insulation removed. Leaving insulation on our commutator coil stops the flow of electricity through the armature. Having the commutator section of the wire ensures that current always flows through the rotor windings in the same direction. The green tape is placed on the coil of wires so you have a good visualization point of where we can determine a force. In this example, with magnetic flux in the upward direction and current to the right direction, using the Lorentz force and your right-hand rule, force in the green tape is pointing out towards the viewer. This can be seen in this depiction of the motor as the rotor is rotating towards the viewer. In this picture with the green tape located on the top of the armature coil, you notice that the commutator coil has the barrier of insulation in between the two conductors. No current through the armature equals no force because the insulation is preventing connection. The circuit has been broken. This can be seen in this video as the rotor does not rotate when the green tape is at the top. In order to spin, the two conductive surfaces need to meet to start the flow of current. This is a video of the actual commutator section. Insulation on the bottom has been removed while all the insulation on the top remains. This is the conductive side of the armature coil as all the insulation has been removed. The view is state 1 and state 2. In state 1, you can see that the commutator is blocking the flow of current so no force is created. Now in state 2, you can see that a current is created through the coils, which then creates a magnetic force out of the page. Starting in the non-operational setting, you need a quick jump start and the motor will run. Four main fundamentals used in this laboratory examination are Gauss's law of magnetism, no magnetic monopoles, Lorentz force, also known as Bill's law, definition of flux density, magnetic flux moves in the north-south, and Ampere's law.